This video is going to be on points of inflection. And a point of inflection is a place where the curve is just going to shift from concave to convex or vice versa. So that might look something like this. You can see up here we have a concave. Down here we have convex. Our point of inflection is somewhere in here. And that's where it changes from one to the other. So, we can find these points of inflection by taking our second derivative of our function and setting it to 0. And solving for x. So, now in this example, we're going to find the inflection point of the equation 1/3 x cubed minus 5x squared minus 20 divided by 3. Well, the first derivative, f prime of x, is simply going to be 3 times 1/3 x cubed, or x squared, minus 2 times 5x. And our constant will go away because the derivative of a constant is 0. So, now that we have this, let's simplify it a little bit. So that becomes just x squared minus 10x. Now, if we take the second derivative, we'll get 2x minus 10. If we set that equal to 0, we get 2x equals 10 and x equals 5. So now what we need to do is, this is our x-coordinate of our point of inflection, but we don't have our y. In order to get the y, you just substitute it back in. So when we do that, we get 1/3 times 5 cubed minus 5 times 5 squared minus 20 divided by 3 is equal to negative 90 whenever you do all that math out on a fancy calculator. So what this looks like is this graph down here. And our point of inflection is somewhere in here-ish. We say this is negative 100, this is approximately negative 90, maybe. So, this is how you would solve for your point of inflection for any other type of curve as well. You're just going to take that second derivative, set it equal to 0, and solve for your x value. Then resubstitute that x back in and solve for your y value.